she, B, and me. All right, now for the next three that we're working on. Find the domain of a function. Now remember how a logarithm looks. It's the inverse of an exponential function. So let me remind you of an exponential. An exponential function has a horizontal asymptote of the x-axis. Most of the time, if it was like 2 to the x power, it would just look like this. So the x-axis is its asymptote, horizontal asymptote. With logarithms, since it's the inverse of this, then the y-axis becomes a vertical asymptote, and this function kind of hugs the x-axis, but it slowly increases, and it looks like this. Logarithms do not equal 0. They just don't. So in order to figure out their domain, what we have to do is we have to take the argument that follows the log expression here and make it greater than 0. Excuse me. So 11x plus 18 plus that x squared, so x squared minus 11x plus 18 needs to be greater than 0. All right, so where does that happen? Where is this greater than 0? Well, when we factor it, we end up with x minus 9 times x minus 2 is greater than 0. And if we go back to chapter 3, where we deal with, number lines and inequalities, you could also graph it just to kind of see where the domain is. But we're going to use this number line first to figure out where this part is greater than 0. And then we'll graph it. All right, my number line's a little bit wonky, but we'll deal with it. All right, so these zeros are 2 and 9. So I'm going to put a 2 here and a 9 there. Try to make these ends arrows so they look like a number line. Anyhow, they're greater than 0, so I'm going to put little open circles, even though, that's where it's equal to 0. We don't want it to be equal. All right, so we're going to plug in some numbers. I'm going to plug in my favorite, 0. Then I'm going to plug in 3, and then I'm going to plug in 10. I don't like to plug in too large a number. All right, so when we plug in 0, we end up with 18. 18 is greater than 0, so indeed, this side of our number line is a part of the situation. When we plug in a 3, 3 minus 9 is negative 6. 3 minus 2 is 1. Negative 6 is not greater than 0, so that's not a part of our solution. And then we plug in a 10. 10 minus 9 is 1. 10 minus 2 is 8. 8 is greater than 0. So, of course, this guy is a part of the situation. So the domain of this function would be, according to this number line, from negative infinity to 2, parenthesis, union from 9 to positive infinity. But let's check it out with the graph. Let's make sure. All right, so I'm going to go down here. I've got some other things graphed in here. I'm living my best life with all these functions that I'm going to keep in here for a later class. All right, so I'm going to do the log, and since it's base 10, I don't have to put anything. X squared minus 11x plus 18. If we hit graph, my goodness, you can kind of see it, but let's make sure we can see it better. So let's start ours off from negative 5 and go all the way to 15, and then graph it. See? Told you. Alrighty then, solving a system by elimination. This is one of our last topics, but we can do it. When we're solving a system by elimination, we need to choose a variable to get rid of, and it should be a variable that has a 1 in front of it, but if we can't find one, we just pick the variable we want to. Here, the variable that has a 1 in front of it is this x right here. Make it a little bit more pronounced. That guy right there, living its best life. What we need to have right here in front of this x is the opposite of the number that's in front of this x. So that means we need to multiply this entire equation through by 5. Now let's watch what happens. When I multiply that equation by 5, number 34 is coming down here. I get 5x minus 15y equals 55. And then I get negative 5x minus 4y is equal to 2. Now, what do? I'm going to add these equations straight down and watch what unfolds. Something gets eliminated. 5 plus negative 5 is a 0. The x gets eliminated. Negative 15 and negative 4 make negative 19y. 55 plus 2 make a 57. And then, we divide by negative 19, and we get y equals negative 3. But let's be sure. You know the all-knowing teacher makes a mistake every day. 57 divided by negative 19 equals negative 3, just like I said. So if y is equal to negative 3, then we can plug it back into any of these equations to find out what x is. I'll just plug it into the first one. X minus 3 times negative 3 is equal to 11. And all I did was replace the y with the negative 3, as you can clearly see right here. All right, negative 3 times negative 3 is positive 9. So x plus 9 is equal to 11. Subtract that 9 on both sides, and you find out that x is equal to 2. This is our ordered pair. You always write them in alphabetical order, x first, y second, and that gives you 2 comma negative 3. There you go. That's our system. So this was the domain of our prior function, and this is our solution to this system right here. Yep. Now let's do this last problem, and then I'll do the final 4 problems in another video. I don't want to hold you too much longer. I've already had you in here looking for hours at things. Rewind the video if you need to see these things written out, or slow it down and try it yourself. All right, now let's solve this log equation and express the solution in exact form. Log of 4 plus x minus log of x minus 5 equals log of 2. First thing we're going to do is to write this side as a single logarithm. So that becomes the log of, what does subtraction tell us to do? It tells us to divide. The log of the first argument, which is x plus 4, over the second argument, which is x minus 5. And this equals the log of 2. Now, both of these logs should always have the same basis, and they both have a base 10. So we could drop those logs like hot potatoes, just like we drop the exponent bases like hot potatoes. And that'll leave us with x plus 4, or 4 plus x, over x minus 5 equals 2. Now all we have to do is solve this equation like we know how to do. We're going to multiply both sides of this equation by x minus 5. Why? Because we're trying to clear the fractions. Nobody wants any fractions in their equations. So we cancel this out, and we're left with 4 plus x is equal to 2x minus 10. How lovely. Let me continue on in blue and put it right up here. Now I'm going to move that 2x over there with the x, because I like my x's over on the left side, and move my 4 over here with the 10, giving me a negative 10. Now, could I move the x over to get a positive x? I could have, but like I said, I like my variables on the left. And I'm going to end up with x is equal to 14, because I'm just going to divide by negative 1 to get the x all by itself. And now I've got it. And I hope you do too. So take your time, review all these sections, learn this material for the first time if it's the first time you saw it, and good luck as you study. See you in our very last video in a few moments.